Welcome back. Previously, we briefly discussed the perceptron, the basic unit of a neural network, a processing element which receives input nodes, and based on the equation of the linear model, takes their linear combination in the first node. Another node, the step function, then checks the score and assigns that point a label of either 0 or 1. That is the basic composition of a perceptron. It takes in input data, processes that information in some way, and finally decides how to categorize that data by producing an output. We also mentioned that when taking the linear combination of the inputs, each input is multiplied by its respective weights. Looking at this equation, age x1 is multiplied by weight 1, and sugar level x2 is multiplied by weight 2. Looking at this, it should be clear that blood sugar has more weight than age. Suppose someone is 50 years old and has 3 millimoles per liter of blood sugar. If we take their linear combination, it results in a positive value of 6, which our activation function would process and return a prediction of 1. If I change the age by a factor of 10, make it 60 years old, it barely changes the value. Whereas if I change the sugar level by a factor of 10, it has a dramatic impact on the score. The input with the highest weight is the one that has the larger effect on the score. And clearly, blood sugar has the higher effect. Its value is much more influential and pretty much dictates whether or not someone falls in class 1 or class 0, whereas age doesn't really have as much of an effect. In essence, the equation of our line dictates how much weight an input has over the other. Before diving into any more theory, let's dive into some code and set up the initial stages of our project.